So I'd like to talk today about ionic analysis. It's pretty straightforward when we have monoatomic atoms. A little harder when we have polyatomic atoms. First of all, how do you know if you had monoatomic or polyatomic? Well, if you look at the periodic table, you'll notice that all elements start with capital letters. So if you see something like this, well, that's easy enough. It's one element. But what if you see something that looks like that? Well, you really don't know if that's monoatomic, polyatomic, unless you knew your periodic table. But there's only one capital letter, so that actually is copper. And let's try another one here. What if you saw something that looked like this? Well, once again, that's one atom, so that's tin because it has one capital letter. But what if you saw something that looked like this? CO3, for example. Well, that has two capital letters in it. It's got a C, that's carbon right there, and it's also got an O, that's oxygen. And there's three of the oxygen there, so this guy is a polyatomic. Now, here's the deal. When you go ahead and do these sort of things, how do you know how many ions you have? Well, it's really simple. No matter what you start with, whether it's polyatomic or monoatomic, it's pretty much going to be two ions because of positive and negative. So let's go ahead and just try one. So if I did something really, really simple, oh, how about this? Na, one capital letter, we know that, that's Cl. And let's go ahead and put the charges on it, positive and negative. I got one positive, one negative here, so that must have been one ion, and that must have been one ion. So I actually just had two ions there. Real simple. Suppose you had a polyatomic, though. That makes it a little trickier. What if I had this? There's that Cu again, and SO4. Now, if you just didn't know anything about chemistry, you'd say, wow, maybe it's like three ions, because I got three capital letters. But here's the deal, right? Let's put the charges in here. That's a +2, and that's a -2. So there were only two ions that we started with. There's one, and there had to be the other. Let's take it up a notch a little bit harder than that. What if you had something that had polyatomics that was balanced? Or, let's see. So why don't we try, how about this guy? How about calcium, right? And let's put in nitrate down here. NO3. Once again, we always have to start with two ions. So there they are. You got a calcium and you got a nitrate. Two ions. But this is not balanced because this actually is a +2 charge here. So we really need two of these guys over here. Since it's a polyatomic, we have to put in parentheses. Now, how do you know how many ions you have? Now, once again, you always start with two ions, right? But we just did it here. In this case, we now have two of these, and we have one of these. Now, where was the one? There actually was a one down there. It's just like math. It's implied. If you don't see it, it's there. So it's really easy. How do you know how many ions you have? You add up the subscripts. In this case, 1 + 2 means we must have had 3 ions. So that's going to be our big rule for today, right? Let's go ahead and summarize it, right? Rule number 1. So it's got to be positive first. No, that's not how you spell positive. Positive, then negative, right? That's the way the ions work. Second rule that we learned here, right? You always start with 2 and then balance with subscript, right? Always start with 2 ions and then balance with a subscript. And how many ions do you know? The ions equal the total of subscripts. Just add up the subscripts, and that should pretty much tell you what you got. Okay, let's go ahead and try some of these, right? How about this guy here? Suppose you had, this is aluminum sulfate, right? How many ions do you have? Once again, let's add up the subscripts. That should tell us here, right? So you got 2 and you got 3. Now you don't have 4 here. Don't get confused with that 4. It's in parentheses here, so it's 3. So 2 and 3 means we must have had 5. Now here's the tricky part. How do you go ahead and figure out how many atoms? In that case, it's just like mathematics. You use the distributive property. You got to multiply things out. Let's go ahead and take a look. So first of all, I'll erase that so you can see it again. How many aluminum ions, aluminum atoms do we have? Well, we got 2 of them. We got 2 aluminums. Now this is tricky though. How many sulfurs do we have? At first it looks like 1, but it's multiplied by 3, right? So you really had 3. And how many oxygens do you have? It's not 4. It's 3 times 4 is 12, so the total is 17. Our transitional ionic compounds are a special situation. The rules still apply on this one when we balance things out, but with transitional you can have several different oxidation states, and the name usually tells you what you need to have. So let's take a look at our name here. So in this case we have iron 2 chloride, so that's going to tell us, right, that our iron is going to have a +2 charge. And the chloride we always know has -1, so let's put it down here. Iron is +2, chloride is -1, so we have to balance it. Let's put a 2 down there, so 2 times -1 is -2, +2, so this would be our final molecule. Now let's go ahead and look at how many ions we have on here. Now remember, if we don't see a 1 down here, it's still kind of implied, right? So how many ions did you have? You have 1 iron and you have 2 chlorides, so you actually have 3 ions here. Let's take a look here at the next one here. What if you have a polyatomic, but you still have a transitional metal? In this case, copper is a transitional metal. They've told us that it's copper 2, so we have a +2 charge here. Nitrate is always -1. We start with 2 ions, but it's not balanced, so we have to balance this guy. Since this is a polyatomic, we're going to put parentheses in there to give us the final copper 2 nitrate. Let's go ahead and do an ion analysis of it. This guy, we only have 1 copper there, +2, we have 2. Remember, always add up the subscripts. So in this case, we still have 3 ions. Hey, how about if we're going to do an atom analysis on this one here? That's a little trickier, right? How about this? Well, you have 1 copper. Why don't we do it this way so it's easier to see? Copper, you have 1. Now, nitrates, you have 2, but let's break it down into atoms. You got a nitrogen in here times 2. So you actually had 2 nitrogens. And oxygen, you had 3, but times 2 means we actually had 6 of them. So our total is 1, 2, and 6 would be 9 atoms is our total. Okay, and that's how you go ahead and do balancing ions.